Deep in the rugged mountains of Utah, a team of U.S. miners began cutting through the rocky surface, expecting to uncover valuable minerals hidden beneath the earth. But what they unearthed was far more than just another deposit. It was a discovery so shocking, so groundbreaking, that it has the potential to reshape everything we know about history, science, and even the future of technology. Experts are now racing to study the mysterious find, believing it could change the world forever. What exactly did they uncover? Stay tuned to find out. The rise of tellurium, a key player in renewable energy. Tellurium, a fascinating metalloid, is at the crossroads between metals and non-metals. It shares traits with both but fully belongs to neither. This rare element, once overlooked, is now gaining global attention due to its growing role in cutting-edge technology. With its unique properties, tellurium is becoming an essential ingredient in thin-film solar cells, one of the most promising advancements in renewable energy. The surge in demand for tellurium is largely tied to cadmium telluride solar panels, which are revolutionizing the solar industry. These panels boast exceptional efficiency, rapid energy conversion, a low-temperature coefficient, and impressive durability. As a result, the market for thin-film solar technology is expected to skyrocket, surpassing $32 billion by 2032, more than double its 2024 valuation of approximately $14 billion. With the world's energy demands rising, tellurium-based solar solutions offer a compelling alternative to traditional silicon-based panels. However, solar technology is just one piece of the puzzle. Tellurium is also widely used in copiers, ceramics, specialized glass production, and even in manufacturing durable rubber products. But it's in the renewable energy sector where its potential shines the brightest. Unlike conventional silicon panels, cadmium telluride modules can be produced in less than 4.5 hours, generating significantly lower carbon emissions, 6 times less to be exact. Additionally, over 90% of a decommissioned cadmium telluride module can be recycled, making it an environmentally sustainable choice for the future. According to the U.S. Geological Survey, tellurium's combination with cadmium enhances electrical conductivity, allowing thin film layers to efficiently absorb and convert sunlight into electricity. As the demand for clean energy surges, experts predict the tellurium market will expand by an estimated $315 million between 2023 and 2028, with an impressive annual growth rate of 9.84%. The race toward renewable energy is accelerating, and tellurium is taking center stage. As production methods continue to advance, making these solar panels cheaper and more accessible, one thing is certain: this overlooked element is poised to become a key driver in the global shift towards sustainable energy solutions. What makes tellurium so crucial that it's driving a global race for renewable energy? Stay tuned. The scarcity and surprising comeback of tellurium. When people talk about valuable minerals, names like copper, gold, silver, and platinum come to mind. But mention tellurium, and most might not even recognize it. This rare metalloid remains largely unknown outside scientific circles, yet it holds immense potential in the modern world. Tellurium is incredibly scarce on Earth. Scientists believe that much of it was lost to space billions of years ago when the planet was still forming. During that chaotic period, extreme chemical reactions caused tellurium to vaporize and drift into space as gas, leaving behind only trace amounts in the Earth's crust. Just how rare is tellurium? To put it into perspective, consider platinum, often hailed as one of the rarest and most valuable elements. Tellurium is just as rare, making it one of the scarcest stable solid elements on the planet. In 2022, the entire world produced only 681 tons of tellurium. To compare, global copper production that same year reached a staggering 21.9 million tons. This highlights just how little tellurium exists on Earth. China currently leads the world in tellurium production, while the United States and other nations work to catch up. Interestingly, America's strategy for increasing its tellurium output is directly tied to its copper industry, particularly the massive Bingham Canyon mine in Utah. Owned by the global mining giant Rio Tinto, Bingham Canyon has been in operation since 1906 and is recognized as the world's largest human-made excavation. The open-pit mine is over 4,000 feet deep, spans 2.5 miles in width, and covers approximately 3 square miles. Over its lifetime, Bingham Canyon has produced around 17 million tons of copper, more than any other mine in history. But what does copper have to do with tellurium? The connection lies in the byproducts of copper extraction. In 2022, Rio Tinto completed construction on a state-of-the-art processing facility designed to extract tellurium from the waste material left behind after refining copper ore. This isn't some kind of alchemy, just smart chemistry. The process involves heating and filtering copper sludge, resulting in a purified form of copper telluride. From this, tellurium can be isolated and collected. Though it may not sound like much, Rio Tinto's facility produces about 20 tons of tellurium annually. That accounts for nearly 3% of the world's total tellurium output, an impressive feat from a single factory. While it may not be enough to dethrone China as the global leader, it marks an important step forward for the United States in securing its supply of this critical element. More importantly, this breakthrough means the world now has an additional source of tellurium, an element vital for advancing green energy solutions. How a rare element is changing solar power. When it comes to the future of energy, few industries are expanding as rapidly as solar power. But behind this growth lies a critical, often overlooked ingredient: tellurium. With tellurium production increasing, thanks to mining giants like Rio Tinto, the biggest winners won't just be the corporations extracting it. The real beneficiaries will be industries and individuals who rely on solar energy, from large-scale manufacturers to homeowners looking for affordable, sustainable power solutions. The numbers tell a striking story. At the end of the 2000s, the total global solar capacity was just 17 gigawatts. By 2015, it had jumped to 50 gigawatts, and by 2022, it had skyrocketed to an astounding 240 gigawatts. Forecasts predict that by 2030, solar power capacity could exceed 330 gigawatts, if not more. This growth is no accident. As governments and businesses push for cleaner, renewable energy sources, solar power has become an essential part of the global energy transition. Unsurprisingly, China dominates this sector, just as it leads in tellurium extraction. The connection between the two is clear. As the world increasingly depends on solar power, tellurium's importance in the industry is skyrocketing. But why is tellurium so crucial? For decades, traditional solar panels have been made using crystalline silicon. While effective, silicon-based photovoltaic cells are costly and rigid, limiting their applications. Enter cadmium telluride, a compound that is revolutionizing solar panel production. Unlike silicon panels, tellurium-based thin-film solar cells are easier and faster to manufacture, requiring less than 4.5 hours per module. The economic benefits are significant. Faster production means reduced labor costs, lowering overall prices. Cadmium telluride panels can be up to 70% cheaper than conventional silicon panels, with production costs of around $0.46 per watt. This cost efficiency makes solar energy more accessible to industries and homeowners alike, accelerating the global transition to renewable energy. But affordability isn't the only advantage. Tellurium-based solar panels offer a level of flexibility that silicon panels simply can't match. While traditional panels require rigid, bulky mounting systems, cadmium telluride panels can be applied to a variety of surfaces, including curved structures, vehicles, and even aircraft. This versatility opens up new possibilities for integrating solar power into areas where standard panels wouldn't fit, making renewable energy more adaptable than ever before. However, no technology is without its trade-offs. One drawback of cadmium telluride panels is their slightly lower efficiency compared to silicon panels. On average, they convert 1 to 6% less solar energy into electricity. While this may seem like a disadvantage, the dramatically lower cost offsets the efficiency gap. By simply installing more panels, users can easily compensate for the lower power output, making them a highly viable option for large-scale and residential use alike. Currently, these panels are primarily used in industrial and commercial settings, where vast amounts of space allow for the installation of thousands of panels. Large-scale solar farms are taking advantage of the affordability and ease of production, ensuring substantial cost savings in the long run. But residential adoption is on the horizon. First Solar, a major player in the cadmium telluride solar industry, has made significant breakthroughs in efficiency. In 2014, the company achieved a record efficiency of 21.1% in lab conditions. By 2016, they improved that to 22.1%. If they can maintain these efficiency levels in commercial models while keeping costs low, tellurium-based solar panels could soon become the preferred choice for households worldwide. With demand surging, supply remains a challenge. Current global tellurium production is estimated at under 700 tons per year. Yet projections suggest the world will need over 200 tons by 2030 to meet solar energy demands. This growing supply gap underscores the importance of every ounce of tellurium extracted. Even Rio Tinto's relatively small 20-ton annual production from its Utah facility plays a significant role in bridging this shortfall. As the world accelerates toward a future powered by renewable energy, the role of tellurium in solar technology is becoming impossible to ignore. But what if tellurium's soaring demand powers the future, but sparks a supply crisis? Stay tuned to discover more. A rare element, powering space, medicine, and more. Tellurium's role in modern technology extends far beyond solar panels. It reaches into space, hospitals, and even everyday materials. This rare metalloid has found its way into some of the most advanced scientific instruments, proving to be an essential component in discoveries that push the boundaries of human knowledge. In February 2013, NASA launched the NuSTAR Space Telescope, a groundbreaking instrument designed to study the most energetic and mysterious objects in the universe. One of its most significant achievements came in 2017 when researchers from Durham University and the University of Southampton used NuSTAR's data to measure the rotation speed of a supermassive black hole at the heart of the NGC 1365 galaxy. The telescope also helped astronomers detect hidden black holes at the center of NGC 1448 and IC 3639, revealing powerful X-ray emissions from the far side of these cosmic giants. None of this would have been possible without cadmium zinc telluride, a critical component in the telescope's detector. But tellurium's impact isn't limited to deep space. Here on Earth, it plays a vital role in medicine. Hospitals rely on this element to produce iodine-131, a crucial isotope for treating thyroid disorders. In small doses, iodine-131 helps manage hyperthyroidism, while higher doses are used in targeted treatments for thyroid cancer. Beyond medicine, tellurium compounds are also used in ceramic pigments, fiber optic cables, and thermoelectric materials, making them indispensable across multiple industries. Even the 20 tons produced by Rio Tinto's Utah facility contribute to these critical applications, proving that this rare element is far more valuable than it might seem at first glance. The high-stakes race for nickel in Minnesota. Minnesota is set to become a key player in the global rush for nickel, a metal essential for modern technology. Rio Tinto, a mining giant with operations around the world, is expanding its reach beyond Utah, focusing on the Tamarack project, a joint venture with Talon Metals. This ambitious mining operation aims to extract vast amounts of nickel, a crucial component in batteries used in electric vehicles, smartphones, and laptops. As the demand for clean energy and advanced technology skyrockets, the U.S. is eager to secure a domestic supply of this valuable resource. Right now, the United States is barely a contender in global nickel production. In 2023, the country produced just 177,000 tons, less than Madagascar, which ranked last among major nickel-producing nations with 60,000 tons. The Tamarack deposit, however, promises to change everything. Experts estimate that once the mine is fully operational, it could produce around 3,600 tons of nickel per day, adding up to a staggering 1.3 million tons per year. This would not only catapult the U.S. into second place in worldwide nickel production, but could also reshape the industry entirely. Tesla, always on the hunt for reliable battery materials, is already committed to this mining revolution. The company has agreed to purchase 75,000 tons of nickel concentrate over 6 years, ensuring a steady supply for its electric vehicle batteries. However, mining nickel isn't as straightforward as extracting other metals like tellurium from copper sludge in Utah. The challenge lies in the fact that Minnesota's nickel is buried deep underground, requiring extensive excavation. The area surrounding the mine is home to rivers, streams, and wetlands, some of which grow wild rice, known as manumin, to Native American tribes. Minnesota itself is famously called the land of 10,000 lakes, making any potential environmental impact a major concern. Nickel mining poses a significant ecological risk due to the nature of the ore it's found in. Unlike iron, which has been mined in Minnesota for generations, nickel is often embedded in sulfide ores. When exposed to air and water, these ores undergo a chemical reaction that releases sulfuric acid, a substance that can be devastating to ecosystems. A 2017 study from the University of Minnesota highlighted this issue, warning that lakes, rivers, and wetlands contaminated by sulfide byproducts would likely be unable to sustain wild rice and possibly other forms of life. In response to these concerns, Talon Metals and Rio Tinto have promised strict environmental safeguards. They claim that a tunnel boring machine will carve out a cement-lined tunnel, preventing groundwater from interacting with the ore. Additionally, instead of processing waste on site, the companies plan to transport the extracted ore to a dry industrial facility in North Dakota, where it will be handled in a controlled environment. Sealed railroad containers will ensure that no contaminants escape into the surrounding land or water. Despite these reassurances, the situation remains tense. The push for nickel is driven by an urgent need for more battery materials, but the potential risks to Minnesota's environment cannot be ignored. The state's history with mining has already left deep scars, and locals are wary of the long-term consequences of sulfide mining. The debate over whether the Tamarack project is a technological breakthrough or an environmental disaster is far from settled. Can new mining technology prevent an environmental disaster, or is Minnesota's ecosystem at risk? Share your thoughts below. The strategic rise of tellurium in renewable energy. The increasing demand for renewable energy has placed a spotlight on tellurium, a rare metalloid that has become a crucial element in solar panel production. The United States, recognizing its strategic importance, has ramped up efforts to secure domestic sources of this valuable resource. Despite some opposition, the benefits of tellurium extraction and its role in reducing environmental waste cannot be overlooked. Tellurium plays a vital role in advancing clean energy. Solar panels that incorporate tellurium-based cadmium telluride compounds have proven to be highly efficient, significantly reducing the dependence on fossil fuels like coal. This transition to solar power results in lower carbon dioxide emissions, thereby contributing to a healthier atmosphere. Moreover, the production of tellurium itself has an environmentally beneficial side effect. It repurposes industrial waste that would otherwise be discarded. One of the most notable advancements in tellurium extraction is occurring within copper refining operations. When copper is processed, it generates waste materials known as copper sludge. Without a specialized extraction system, this sludge would typically be disposed of as industrial waste. However, through innovative recovery methods, tellurium is now being separated, purified, and redirected into clean energy solutions. This advancement underscores the increasing efficiency of resource utilization in modern industry. A key player in this field is Rio Tinto, a global mining corporation with a history of extracting valuable elements from industrial waste. The company has demonstrated its expertise with lithium production at its pilot plant in California, where waste rock is processed to yield lithium, a crucial component in battery manufacturing. By 2021, this facility was already producing 10 tons of lithium annually. Plans were also in motion to scale up production to an industrial level to extract at least 5,000 tons of lithium per year. This would provide enough material to power approximately 70,000 electric vehicles. Similarly, Rio Tinto's scientists in Canada have developed methods to extract rare scandium from the waste generated in titanium dioxide production. These efforts highlight the company's commitment to sustainability and resource efficiency. Now, with tellurium, the company is taking another significant step toward optimizing industrial byproducts. Despite its advantages, tellurium-based technology has faced criticism. Some environmentalists argue against the use of cadmium telluride compounds in solar panels due to the toxic nature of cadmium. Concerns about safe disposal at the end of a solar panel's lifespan, typically 25 to 30 years, have fueled ongoing debates. While recycling offers a solution, early cost analyses in 2013 suggested that recovering cadmium and tellurium from used panels was more expensive than simply discarding the materials. However, new methods are continuously being explored to make recycling more efficient and cost-effective. One promising technique involves vacuum distillation combined with mechanical processing, which could potentially recover tellurium at an impressive purity level of 99.92%. Unfortunately, this method has not gained widespread adoption, leaving the industry to seek alternative approaches. Nevertheless, these challenges have not deterred major companies from investing in tellurium production. The demand for tellurium has only continued to grow. In 2020, First Solar, the world's leading producer of cadmium telluride solar panels, expanded its operations by opening a new manufacturing facility in Ohio. This plant boasts an impressive production capacity of 3.5 gigawatts, reinforcing the company's commitment to large-scale solar energy solutions. Rio Tinto has also secured an agreement with First Solar, ensuring that all the tellurium it extracts undergoes refining before being incorporated into high-performance solar module tools. The significance of this development extends beyond renewable energy. By increasing domestic tellurium production, the United States is actively reducing its reliance on foreign suppliers, particularly China, which has historically dominated the market. Rio Tinto's strategic initiatives have positioned the company as a key player in bridging the supply gap between the US and China, securing a stable future for tellurium-based technologies. Looking ahead, the demand for tellurium is unlikely to slow down. As the global transition to renewable energy accelerates, the need for efficient solar panels and other high-tech applications will continue to rise. Rio Tinto's ability to extract valuable resources from industrial waste has proven to be not only an environmentally responsible strategy, but also a highly profitable one. The evolution of tellurium production represents a significant step forward in the pursuit of sustainable energy solutions. What do you think makes tellurium so crucial that the US is racing to secure its supply and reduce reliance on China? Share your thoughts in the comments and don't forget to like and subscribe.